Hey, what's going on, guys? Makefile here. In this video we're gonna be implementing a PERFT driver, and the entire PERFT testing would contain two parts, so the PERFT driver and the PERFT test function. And the reason for doing this is the following. So the PERFT driver itself is already actually capable of answering the simple question whether the number of nodes traversed within some given positions is actually correct or not. But in the case if there might be some bugs occurring within the mode generator or wherever else, say in the attack tables or somewhere else, then the problem would be incredibly difficult to allocate, because we don't know which particular root node, root move, the particular bug refers to. So that's the reason for creating an additional perf test function that would be printing the nodes traversed for every single root node. So you can then just compare these values with some sort of already available working perf tests, and that's the way how you can actually compare your own node generator that might contain some bugs with those that you know for sure works kind of all right and fine. Okay, so I'm sorry, I'm not really that good in explanation, so I would rather just start coding and then you'll see like how it goes. So in this video in particular, we're supposed to be implementing the core PERFT driver function, serving the purpose actually of counting the nodes being traversed recursively within the given depth. And next video will go for implementing the full-blown perf test for this debugging purposes, for the extended debugging purposes. So let's actually start. The very first thing we'll need to make use of is a variable called nodes. So node is also known as the leaf of the search tree, and they also call this like the leaf node. So the particular position where we end up basically. So this nodes is something we can later on compare with existing results of how many those nodes should be there. So I would rather go to chess programming Wikipedia and show you this visually. So let's say chess programming perf results like this, and it should give me a page. Yeah, perf results. So I want to be testing this with two positions: the initial position to the depth of 6, this one, and here we have the number of nodes that our mode generator, that our perf test should show us basically. So these numbers, and also we want to be testing this with so-called tricky position, serving the purpose of tracking the most popular bugs within the mode generator, like bugs on peasant captures, or if there is something wrong with the square attack function or something, or with the pawn promotion. So this one. So we want to be testing with these two positions and comparing the numbers of how many nodes we have, and of how many nodes there should be, and how many nodes we have in our mode generator. Okay, so just to give you an idea. So let's go. So that's the reason for defining the nodes variables. So just call this leaf nodes, or like number of positions reached during during the test of the move generator at a given depth. It's a little bit too long for the commentary, but still it's quite pretty important. So number of position reached during the test of the mode generator at the given depth. So this would be the type long, because there might be really lots of nodes. So integer doesn't have enough bits, so long type is just the case. So long, and I call this nodes. And as far as that, assuming that global variables in C programming language, assuming the GCC compiler are always initialized to zeros. I'm not gonna be saying like nodes equal to 0 because this is 0 by default, and that's just enough for us. And the next function to implement would be the PERFT driver itself. So I simply create the, let's make it static inline to make it faster. So static inline void PERFT driver, and the only argument it would be taken is the depth. Okay, so we'll start with a escape condition because this PERFT driver is the recursive function that would be calling itself recursively. So I just call this recursion escape condition. So we can simply say if depth is equal to 0, that means that we need to first we need to do two things. So the first thing to consider, we need count nodes. Well, actually, we technically this is the matter of incrementing the nodes variable like this. So we say just nodes plus plus. But here, actually, we let's say increment nodes count, and here I just say like count reached positions like this. Yeah, and obviously we need to return from this function. That's kind of it. Sorry, depth has a typo. Okay. By the way, let's actually try to compile and run the code along the way to make sure it doesn't have any typos. So make debug, and if it makes, I just want to run the BBC binary executable. Okay, so gives the output from the previous part, which we don't really need, but that's just fine. Okay, so the next thing to do within this perf test, I actually want to create a move list and generate the moves for a current given position that would be initializing here within the parse.fn. And by the way, I already want to go for our tricky position. So this sort of a position. So we'll start generating moves with this position, because if there are no bugs within this position, then almost 100% sure that won't be any bugs within the initial position as well. So we'll enclose our perf test within this timings, but obviously when it comes to to implementing the perf test function, it would be done within the perf test. But just right for now, I keep it here to show you like how the time taken for the perf test is calculated, and also what's the difference between if we compile this with optimization flag and without optimization flag. So the difference would be quite pretty significant. Okay, and the very last thing, I just want to grab this loop over the generated moves, so we don't need to print the board or pause in the workflow here. So this is not needed really, but we want to call PERFT driver recursively, and the idea here is that we just, so first we're generating moves for say white pieces and making all the moves, and in response to all the moves made by white, we need to generate the response made by black, and then again response made by white. So so this sort of behavior is reached via this recursive perf calls, and exactly the same idea would be working within our NigaMax search. So perf already introduces this, but the difference would be that within the alpha beta search we would be using so-called alpha beta pruning to traverse a really minimal number of nodes, while in perf test we need to make sure that we're traversing all the nodes, and that's the exact way how to test whether the move generator is actually bug free or not. So here I just want to say like PERFT driver and depth -1. So just the classical recursion implementation here, nothing much really. Okay, and already this, if I did everything correctly, this should work in theory already. So let me just have a look. So okay, we'll loop over the moves, initializing the move. Well, if we don't do this, it would be going even faster actually. So let's actually make this, because we really want to be it faster. So let's avoid unnecessary stuff here, because we need the true power the true power and speed of our mood generator. So we just preserving the board state, making a move, calling perf recursively, and then later on when the stack I'm not sure rewinds, apparently the word rewinds, yeah, rewinds, probably rewinds. As soon as the stack rewinds, it will be taken back, and assuming that we're storing our board here on the stack of the PERFT driver function, and we're calling our copy board macro only once, this is literally enough to make it work. Okay, so without further ado, I would actually like to call the PERFT, so PERFT, and just say PERFT driver, and let's start with a depth of 1, and it should give us, so I don't really need this get character at the end. Yeah, I would be testing this for Windows starting from the next part, I guess, starting from the next video. So now it should give me 48 nodes, and yeah, I didn't yet provide a print statement to print it actually, so I just want to say printf and nodes, and this would be the long decimal followed by the new line, and nodes and nodes variable like this. So let's have a look. Okay, so a few arguments to make move function. Oh, just a typo here, sorry for this. Okay, so we got this 48 nodes. Obviously it didn't take any time, so 48 nodes, exactly the number. So let's go to tricky position. So we got okay, yeah, we got this 48 nodes for the depth of 1. So at the depth of 2 should give us 239 nodes. Let's have a look. So I will now just change the depth to 2 plies. Okay, and here we have 2039, which is the exact number we need. So at depth of 3 we would be having this 97862 value, hopefully. So let's run this at the depth of 3. Okay, so this number is correct, good. And then let's go for the PERFT test of 4. Okay, now it takes a little bit time. So this is the number, and this is exactly the same number we have here. So just for you to compare, guys, see, like this number, and this one, they are the same. But if I now just try to make it a search for 5 ply depth, it would take really long time without the optimization flag. So just to give you an idea, so it takes 1 second and a little bit more without optimization flag at this position. But if instead of make debug, I would just simply say make and run BBC, this would be using the so-called -oFast optimization flag for both Windows and Linux versions. Yeah, for both versions, and it should go really faster, but it takes longer to compile the sources to apply all those optimizations. So just to give you an idea for this comparison, well, probably because it is slightly faster, but it's hard to see within this tiny searches. But just trust me, if we go for the depth 5 without the optimization flags, it would really take ages to complete. And another idea behind additional PERFT tests, so why to implement this, to actually see dynamically how the nodes are getting traversed for every root move. So we would be printing every root move along the way instead of blind expectation until it's done, basically. So it needs to traverse 48 moves, which is quite pretty a lot, basically. And yeah, so I would probably, it would probably be better to just to go for the initial position and try it, say, at the depth of 6. That would be much faster for about 7 seconds only. So yeah, it just takes too long, so probably just drop it. And let's go to the start position, because I don't really want to take your time too much. So start position, depth 5, and we should get there at the depth of 4 million. Yeah, and then we'll go to the depth of 6. So let's try depth 5 at the start position. Okay. So let's try start position at the depth of 5. Okay, so this is the number. Let's compare. So 4865, 4865, 609, 609, perfect. And now let's go for, so time taken is 2 seconds. Okay, and now let's go for the depth of 6. And it should, and with the compilation flags, it should go for about around 7 seconds. Well, maybe 8 seconds, assuming that I have my video recording software running and the web camera view, which obviously slows down, which obviously takes the processing power, hence slowing the perf down slightly a bit. But still, it should be completed for about 7 or 8 seconds, things like that, and it should get done. Okay. Okay, 30 seconds. Well, strange, this is a little bit too long, but well, anyway the number, hold on a sec. Yeah, the number of nodes is just fine, but for some reason it takes too long. This is a little bit strange. Yeah, so the number 119.119.060.060.324. Yeah, so the good news is that actually the nodes traversed, the number of nodes traversed is fine, which means that 99% the move generator that we've created is bug free. And something very strange here is, I'm not really sure why it takes up to 30 seconds. Is this because of my recording software? Because when I did that comparison of 4 mood generators, exactly the same mood generator took only 7 seconds. Okay guys, so I will definitely figure that out and just try to find out like kind of what was wrong there, and I'll share my insights in the next video. And also in the next video, if if I don't find some horrible bugs, then in the next video is supposed to be writing our perf test to also print some leaf nodes for our root leaf nodes for the root moves. Yeah, that's it. Okay guys, so this is it from my side. Thanks for watching. I hope to see you in the next video. Until then, and take care. Okay guys, just a little postscriptum after the video. Just realized the reason why this was so weird. Actually, we were running this without optimization flags, and I was thinking that I just made a mistake while typing this -oFast. It should be. By the way, I have no idea why this didn't give me an error. Probably this flag is legal as well. But what we should do here is actually we need to say -o big and fast from the lowercase, and the same here. So -o big and f from the lowercase. And all the time the makefile was actually a bit wrong here, but as far as we didn't use it before, yeah, unfortunately I didn't see that. So with this correct flags, if we just try to compile and run the source code again, now it really takes longer to compile. You see, like it takes time to compile, but it now should take only for about 8 or 7 seconds to complete the entire perf test here. Yeah, just what I was mentioning, like only 8 seconds instead of 30 seconds, because we were having all of this optimizations flag. So this is the exact number I just wanted to show you guys, and without this video recording software, it would be for about 1 second faster. So that's kind of it. Obviously the number of nodes traversed is still the same. So just please fix this -oFast flag within the makefile in case if you're using the makefile. And for those of you guys who is actually using the IDE in order to who is most likely on Windows and using the IDE to develop this program, you most likely you probably would have this 30 seconds result. So if you are having that 30 seconds result, make sure that, I'm not sure how exactly that is done within the IDEs because I never use them, but there should be some compiler optimizations available. And if you have an ability to add the flag to your GCC compiler somewhere in the IDE, please make sure to add this -o, big O, and fast from the lowercase. So O from the uppercase, F from the lowercase. I'm really sorry for this little bug here, yeah, but just wanted to make sure that you change this on your site. And please let me know in the commentaries if you succeed to compile this with the optimization flags, and if not, if you have any issues, please leave the commentaries pointing to those issues, and we'll try to find the solution together. Okay guys, so now I'm sure that the next video will be dedicated to the perf test function that, well, I've been describing this already, so I'm not wasting your time anymore. Until next time, and take care.